Ladies and gentlemen, boys and girls, welcome back to another video. So, let's see, man. We've got, this is Webassign problem 1.3.5. So, 5. Calc 2. We've got that this length here is going to be 6, and we've got that this radius here is going to be 2. Yeah, I make it in red, so we can... Okay, here's 2. Okay, and so how do we do this? So our hydrostatic pressure equation, right, is going to be F equals the integral from A to B, and this is like here is your depth, right? Same as our pumping, like our tank pumping problem. We're going to have our depth, and then we're going to have a rho of y. I guess rho normally doesn't change. Rho times L of y. So L is going to be the length of your face, right? And then we're going to have your depth kind of like h minus y, right? So here we're going to have h minus y dy. So h here is how high it is. This is height. So let's get into solving this. When we solve, we are going to have, if we plug this stuff in, right, we have that rho is 62.4. So you know that this guy here is going to be the integral of 62.4. And what is our length here, right? The length is a question, because the length is changing. At this point, it's 2, but at this point, it's 0. And then at this point, maybe, or okay, so maybe it's 2 times 2. So this is 4, and this is going to be like, this down here is 2, 0 here. Right, so how is our length changing? Well, our length here at any given point, y, our length is what? It follows this circle here, right? The semicircle. So if we call this guy here 0, so we're going to call this line 0 here. If this here is y equals 0, well, then this curve should be following the circle. This curve here is going to be x squared plus y squared equals 4, right? So then our length is actually going to be not only, because that's x, right? This guy here is x. So our length is going to be 2x, right? Because this double this x is L, right? So we solve for x. So we're going to have that x squared equals square root of 4 minus y squared. And we, sorry. X equals, x squared equals 4 minus y squared, right? That means we take our square root. So x equals plus or minus 4 minus y squared. And which one will it be? Should be the negative one here, right? Because my apologies. I'll have to crop that in. I was doubting myself. This should not be negative. This doesn't matter. It doesn't. Okay. This does not matter. Okay. My apologies. So x is squared 4 minus y squared. Now y is negative, but it doesn't actually really matter. So x is going to be positive here. And then, so now we've got this, so that means that L is going to be 2 times square root of 4 minus y squared. Here we are. All right, so L now is going to be times 2 root 4 minus y squared. And now that we've used the convention here that this is y equals 0, that means that our convention here has to be that we're going from 0, our height is 0. And what is our depth then? Our depth, we're doing this from -2 to 0. Okay. So now we've got this, we just solve this out, right? We solve this out. This is going to be 124.8 times the integral -2 to 0 of these come out, and we're going to have negative, so maybe this negative comes out here, this negative from negative y. is going to come out, and then we're just left with y root 4 minus y squared. So now we say that u equals 4 minus y squared, du equals negative 2y, and we can actually have our negative 2 fine. It's going to be 62.4. This is negative 2. We're going to divide here. So then we have our negative 2 dy. This means that this is going to be equal to 62.4 integral negative 2 to 0 of square root of u du. And actually, these are not negative 2 to 0. It's going to be u-bounds. What are u-bounds going to be? So when u equals negative 2, y equals what? Sorry. When y equals negative 2, what is u? Y equals negative 2. This means that u is going to be, well, u is going to be 0, right? Because here we notice that that we plug in here. This is to give us 0. Right? Now when y is 0, what is u going to be? 4, right? So now we're integrating from 0 to 4. So now we do our 1/2 up to 3/2 and divide. So this is going to be 62.4 divided by 2/3. U to the 3/2 evaluated from 0 to 4. And now your final answer should be 62.4 divided by 3/2 times 4 to the 3/2. And so then maybe if we simplify it one more time, this would be something like 62.4 times 2 times 4 to the 3/2, which would just be 8, all divided by 3. This would be your final answer. Okay, wonderful. We're happy with that. Let's go ahead and do this problem. And then I will get you guys, number 7, you guys should be able to figure out with which is the stuff that we've done. Wonderful. Delete this, go back in. So we'll go ahead and copy this here, and we'll shrink it a little bit, and then we will say, we'll start getting into our business. Okay. So we have here, allow me a moment, please, I'm finding my work. I cannot find it. .3.6. Okay. This guy here is 1.3.6. Okay. I wrote that maybe poorly, but it's fine. And so we've got a vertical dam. It's got this thing, this triangle, right? We're just doing the same hydrostatic force, right? Okay. So how do we do hydrostatic force? So first off, we know that force is going to be equal to the integral from 0 to this guy here is going to be y equals 0. We have to find our height. So how do we find the height? Well, we're going to make our little triangle here because we're just trying to find the force on the triangle, right? So if this is 6 feet, we can bisect it and make each of these 3, right? And this is 6. So to find the height, h squared plus 3 squared equals 6 squared, which means that our height is going to be the square root of 36 minus 9, right? So what is 36 minus 9? I don't know. What is 36 minus 27? That's right. Yeah, okay. So root 27 is our height. Okay. So our depth here means that we're going to be going from 0 to 27. And then the depth here is going to be 25 feet. So here our depth, 25 feet. Which means that at any given point, so we're going to have rho, which is 62.4. We're going to have L of y. We'll figure that out later. And then at any given point, we are going to have how much water on top of us? Well, we're going to have 25 minus y water on top of us. This is water on top. And this is where your shape lives. And then this L of y here is going to be the length of a slice. Length at a point. At your point y. And this is going to be changing, right? As we go here, our length is this, but as we go up, our length is only this, right? So our length definitely should be a function of y. Okay, so now we have to find y. So how do we find y? Let's see. So we can do these similar triangles again. So we're going to have our length divided by our height. Length divided by height is going to equal, length divided by little h. And little h actually is y, right? So at our y, okay, maybe not. We'll still take a step back. We'll take a step back. Length divided by height is going to have to be the same as our ratio up here. And what is our ratio up here? This is going to equal, what is our total length? It's 6. And what is our total height? It's root 27. This means that L is going to be 6 over root 27 h. Okay, cool. But height is not really y, right? Y is going to be, it's like when h is something like, you know, maybe let's say we're at this point that h is 2, right? So this is 2, and we're living in this big triangle, right? Of course. So when h is 2, really y is this here, right? So y is really going to equal what? The total 6 minus the 2. This is going to be h minus 2. Okay. Which means that h is y plus 2, which means that L is going to be 6 over root 27 times y plus 2. Okay, now we've got everything done. Now we can just go in here and we can say that f then, by this little argument, is going to be the integral from 0 to root 27 of 62.4 times L, which is going to be times 6 over root 27, y plus 2 times 25 minus y dy. And you can solve this out. I will not do it, but this should be something like quadratic in nature. You just do your power rule, and you don't even have to do use. Very easy. Okay, so this would be your final answer here. That's how you'd get it. The last question, right? We can just look at it real quick. This cube-shaped water tank, something. You know, now what you need to do is you need to solve for h, right? So really, this question, you would be setting up an integral, something like integral from 0 to question mark is going to be 62.4 times your given length times, you're given something minus y dy equals 200, right? Now you have to solve for this. You do your integration. When you integrate, you're going to have something of the form like h squared, or sorry. It'll be like y squared minus yh, something like this. I don't know what it is. And you're evaluating from 0 to h or something like this. And then now you have to figure out what value of h makes this true. So h equals something. Okay. I hope that you all enjoyed that. If you have any questions, please feel free to email me, and I will see y'all tomorrow. Later.